Next, we'll just dive into logic diagrams, and I'll show you how to write algebraic expressions for these. And then we'll go the other way around. We'll start with algebraic expressions and draw the related logic diagrams. Let's just dive right into this one. Here I've numbered the gates to help us identify them. We don't need to. What I'll also do is label them, just so we remember what they are. So gate number 1, it looks like an AND gate, but because it has a not dot at the end, it's actually a NAND gate. So it acts as an AND with a negation. The second gate, with the input of just C, is a NOT gate. And finally, gate number 3 is a regular AND gate. Let's look at gate number 1. What are my inputs for gate number 1? Well, I have A going into it and B. So both A and B go into the gate. It is a NAND gate, so I'm going to have A multiplied by B, but with the negation over top for the NOT dot. Going into gate number 2, the NOT gate, we simply have C. So out comes not C from that. Our third gate has 3 inputs. The first one is not A and B. Not A and B. It's an AND gate, so I'll multiply all the inputs together to show the additions, show the AND. The second input is B. So far we have not A, B, and B as the inputs. And then the final input is not C. Try drawing a truth table for this algebraic expression. Let's try some more. I strongly encourage you to pause these and try to write the algebraic expressions on your own. And let's see how we do. Got 4 gates here. I'll label them just for ease of identification. And I'll write down what they are. Here we've got an AND gate. I'll call this gate number 2 just because it's the second AND gate. Gate number 3, well, that's a NOT gate, so that will be a straight negation. And then finally, gate number 4 is an example of an OR gate. Let's look at the input for each one. Gate number 1, the AND gate, has inputs A and B. So we have A and B, signified that they're a dot in between or simply writing them next to each other to indicate that they're running through an AND gate. We can think of this as multiplication. For the NOT gate, we only have an input of B, so out pops not B. And then not B and A are both inputs into the second AND gate. So we have A and not B. Be careful to write the not only over the B, as the input A hasn't been negated. Finally, both of these inputs go into the OR gate. So we have A and B, or we'll signify the OR with a plus sign, A and not B. And that's it. Could have written this next to the F to say that this is in fact the output. Here F is just a stand-in for the final algebraic expression. Have a look at a truth table for this output as well. Let's do one more. This one's quite busy, so let's break it down once again by gate and then have a look at the input for each one. All right, I'll number these again just so I can talk about them. This is a NOT gate. And then we have the output from that NOT gate as well as another input that we'll follow through later running through an AND gate. That's later negated, so really an AND and a NOT together could have been written as a NAND gate. This one's a little tricky to see. It's not written as a classic OR, but because it has a curved back, so this is number 3, so I'm talking about gate number 4 right now, this is in fact an OR gate. Number 5, that is strictly written as a NAND gate, not as an AND and a NOT, all together as one, so we'll indicate it as such. Gate number 6 is an AND gate as well, and below it, 7 is a NOT gate. You certainly don't have to label these. I'm just doing this for convenience, and so that I label them once, I think it through once, and then I can simply follow the inputs and write the appropriate outputs. I don't have to think about what type of gate it is each time. In any case, this is our first example of an XOR, not an XNOR. It doesn't have a not dot, it's simply an XOR gate. Do you remember how those work with truth tables? It means one or the other, but not both. Keep that in mind. Okay, let's trace the inputs through each gate, and after we go through each gate, we'll write down the algebraic expression. So we have an input of A into our NOT gate, so our output is not A. I'm not quite sure what goes into gate number 2 yet. I know I'll have not A, but the rest is a bit of a mess, so maybe we back up here. Let's look at gate number 5. It's got 2 inputs, B and C, and it's a NAND gate, not AND. So we have B and C with a negation, or not B and C. B also goes into gate number 6, an AND gate. And the second input for gate number 6 is the output not BC from gate number 5. So the output for gate number 6 is B and not BC. Maybe you want to write that with a dot, B and not BC. Now I notice that B and not BC also goes into gate number 2, an AND gate. So we have not A coming in, and our second input into the AND gate, so I'll use multiplication, is B and not B and C. Then that whole mess, not A and B and not BC, goes through a NOT gate. So the output here is not A and B and not B and C with a negation over the entire piece. All right, that's followed through the top so that we know what our first input is for the OR gate, but we haven't completed the bottom yet. So coming out of gate 5, we had not BC, and that output went into both gate 6 and also goes into gate 7. Another negation, another NOT gate. So we have not BC. And if you're immediately tempted to write this as simply BC, recognizing that 2 nots will cancel each other out, you're absolutely right, and we'll look at that in the third portion, in the third part of this. All right, coming out of that NOT gate, not B and C, that's our input for gate number 8, the XOR gate. All right, what's coming into gate number 8? I'll write it over here. So we had the output from gate 6, which was B and not B and C. If I run it through an XOR gate, I use this symbol, the plus with a circle around it. And the second input is not B and C. Not B and C. All right, so we have our 2 outputs, not A and B and not B and C. That's our first input for the final OR gate. The second input for that final OR gate is B and not B and C, XOR not B and C. All right, let's write that out. I'm simply copying the 2 inputs, and then because I'm running them into an OR gate, I'll put a plus sign between them. And because of the order of operations and the fact that the OR gate will be last, I don't have to put brackets around these halves, but maybe you want to indicate for yourself that these 2 inputs came from separate chains, and then finally we run them through an OR gate. If we were finally running them through an AND gate, we'd have to be careful about indicating the brackets. But because OR is applied last, We don't need to in this case, but it doesn't hurt to over bracket. If you think this looks like an awful mess, you're absolutely right. There's got to be a better way to write this. And again, that's where we're headed in part 3. We're looking at our algebraic expressions and seeing whether we can simplify them. For now, we're just writing them, exactly as given by the diagram. Could we have made this diagram easier and had the same output? Probably. That's again where we're headed. That is the point of part 3.